Hello, welcome back, my dear students. This is the practicum part or the math part of chapter 9, which is forecasting. Forecasting. Forecasting is trying to predict the future, trying to see how the future looks like. This is the meaning of forecasting. Forecasting, it depends on two ways usually. The first way is a subjective forecasting, which depends on the opinions of the people who are working in the management. As example, if I say there is a factory now is producing and selling every year, the selling is escalating. Like every year there are more selling than the previous year. Then I will collect the people who are seniors in the management and tell them, give me an idea about what's going on. Okay, in the future, are you expecting that we sell more or sell less? Sell less. Then they would say, we will sell more because based on the previous data, the historical data, which said that they are increasing in the levels of the volume of sales, that means in the future the sales will be more and more. This is all based on people's opinions. And people's opinions might be right and might be wrong. This is we call it subjective forecasting. Subjective means depend on the people opinions, and this might be wrong or right. Who knows? No one expected the COVID, what the COVID will do the whole world now. So you can say this is not very acute way of forecasting the subjectives, because people's opinion differ and vary from a person to another, and at the same time the estimations of the people might be wrong because there is the personal error. That is the point. We said there are two ways for forecasting. Forecasting means seeing, exploring the future. Planning, forecasting or planning for the future. The first way we said the subjective way. Don't forget the subjective way. The second way is the objective way. So if the subjective is qualitative or descriptive or depends on the opinions of the people, whereas the objective one, no. The objective depends on quantitative approach. Again, the objective depends upon the quantitative approach. And the meaning of quantitative approach is that it depends on the math or the mathematicals. The mathematicals approaches, like as example, we will see the moving average in the forecasting. We will see the second thing, which is the stranded chain analysis and the least squares, and how to get the regression model. Those are all ways to forecast, and those ways actually it gives us a very punctual results, which is more accurate than the ways the subjectives give us. Let's move to this chapter and take the quantitative approach first. Then as we are together, like, because in the start itself of the class, I would like you to know the practical part, then we will move to the theoretical part. Okay, let's go to the first thing is I will go to page 13, page 13, or the slide number 13. Slide number 13. Okay, this we call it the time series forecasting model. Let me share the screen. Yeah. So here we go. So this is the time series. Here we go. Here is the time series forecasting method. From the name itself, time series forecasting method. What does this method depends upon? The method depends upon that The end of the week, look at this, look at this. The end of each week is the start of the next week again. So let's say in a hospital, there are 84 patients this week. Then I believe that the next week, the end of the first week, 84, then the start of the next week will be 84. So that's why we say time series forecast. But this way of forecasting, it depends only on a very short period of time. You cannot forecast more than 1 week in advance, or 1 month in advance, or 1 year. If you have the data of 1 year, you cannot, because you just only moving one step ahead. Okay, so let's complete this schedule and see what's going on. The next week is 81, then it will be the start of the third week. We will move it. So if we do 84, it will go to the next week to be the start of the next week. 81, huh? We'll go 81. Okay, 89 here, the end of the third week is 89. Then you expect that the start of the next week or the fourth week will be 89, which stopped in the, okay, how about this 90? Look at this, 90 came here, the same thing, 99, 99, 106, 106, 127, 127. Okay, here is 117 for week number 8. Can you give me the number of the patients estimated or forecasted for the week number 9? I have only till week 8, but can I get 9? Yes, I can get 9, because it is the people of 8, 117, I will move it here. So if I give you as example, let me now stop share and give you an example like this. I told you I want the time series forecast, and I gave you a chain of 3 years, a chain of 3 years like this. Okay, this is year 1, this is year 2, this is year 3. And I asked you for the year number 4. Then I asked you for the year of number 4. What is the year of number 4 would looks like? Okay, here and here. So year number 1, numbers which I have is 100, 110, 130. Okay, and I asked you here, this is would say here 140. Okay, and I asked you for year number 5. I hope that it can come here. Let us extend it just a little bit. Of course, and I told you just complete for me this schedule. Complete for me this schedule. Okay, this is, I don't have the previously of it, but this will be 100. This will be 110. We will move like this. This will be 130. Then the required year, which is year number 5, I put question tags here. I will take the 140 of year number 4, and that's it. And that is the first example. So that is the way, if you got it in the exam, either vertical or horizontal, it doesn't matter. Doesn't matter if it is vertical, if I gave you this data in a vertical, or if I give it to you horizontal, it doesn't matter, as long as you know how the way to use it and you know how to get the results like this. I'll share back the screen. Like you see here, the number of patients for the period is the number of patients for the next period, and etc. That's how it works. Okay, this we call it time series forecasting method. When we call it particularly last period forecasting, last period forecasting. So if I told you estimate by the last period forecasting, then you will do it through the last period forecasting with this method only. And don't expect that I will ask you for a last period forecasting more than one period, because it's like it's the end of something at the start of another thing. Okay, the end way to your door, your house door, is the start of the road, because you open, then you go to the road, right? That's the way. So end of something is the start of the new phase, and this is the idea of it. Okay, let's move on now to another step or another example, and we will go to slide number 17. Whatever I skip here, you also skip. You also skip. So you will tell me now, oh, what is this? This we call it 2 period and 4 period moving average, and we can use 3 period moving average, and we can use 5 periods moving average. And what do we mean by the moving average? If he tell you 2 periods moving average, you will collect each two numbers and and you will divide them by two, then put them in the following. I will give you an example, and it will be complicated like this in your assignments. I will give it to you very easy one, but I will explain to you all of it so you can all guys do it. In 2 periods numbers as example here, as you see here, this is the patients, the number of patients in the first week. And this is the numbers of patients in the second week. Okay. So what I will do is, let us say here it was unknown. It was unknown. How will I get this number? How will I get this number back? Very easy way to get it. So based on 2 periods forecasting, based on 2 periods forecasting, I will add 84 and 81 and divide them, because I said 2 periods. So I will add them and divide them by 2. So let's say in a white page here, let me say here as example, 81 plus 84, then those together divided by both of them. If we say they are a sum like this way, then I will divide them by 2 equals, this will give me 81, and 84 divided by 2 will give me 165 divided by 2 will give me 82 and a half. Let's go and see the result. Was it like this way? Let's see. Let's see back. Let's see back. Was it like this way? I will go back to where I was. Yes, it was 82 and a half. Okay, let's go for the next one. Can you do the next one? This 85. Can you show me how we get the 85? Can you show me how we get the 85? Okay. What I will collect together, what I will do here. So I want you to do it with your hands. I want you to give me this number here based on 2 periods moving average. Okay? Based on 2 periods moving average. Yeah, someone said we'll take the next number from up and the last one. And so there are two numbers. I won't take the 84 this time. I will start from 81. 81 and 89, this is 170. Let's see. Let's calculate it. I will take 81 plus 89. Okay, see here. 81 plus 89 equals 170. Then I divide it by 2, because I said I'm using 2 moving average. Okay, so it will give me 85. And this is the answer. It was already 85. Let us see. Let us see. Yes, it was already 85. Come on, see, come on, watch it. We'll see it back, how it was. When I return it back, 85. That's how it is. Okay, why don't you show me the 89 and a half, this one? Can you do it with your hand? I want you to do it with your hand. Okay. So you will start the previous two numbers before the one which is parallel to what you want. Okay. So the two previous numbers of this line is this and this, 89 and 90. Okay. Let us see 89 plus 90. Let us see 89 plus 90 will equals 89 179. Okay, divide by 2 will equals, let us see by the calculator, 179 divided by 2 equals 89 and half. So this will equals 89 and half. Okay, now we will see together the 89 and half. Was it like this? Was it like this? I will return it back the way it was. Yes, it is 89 and half. And etc. till the end of the two periods moving average forecast. You will take the previously two periods before the one parallel to what you want. As example, I want this is unknown now, okay? This is unknown. So I will take not this 99, the one before it and the one period. Because why two numbers? Because I said two periods. Okay, so I will take the 90 and I will take the 89, add them together, then divide them by 2. Divide them by the number 2. So it will give me the estimation which I want, which is 89 and a half. Okay, someone will tell me, how about the four periods? The four periods moving average. How can you do this? How can you do this? Okay, it's the same idea. It's the same idea. Like, but instead of dividing by 2, like here we divide by 2, we will divide here by 4. Why? Because he said 4 periods. Okay, let's do the first example, which is 86. The 86. I will say from where this 86. Okay, then I will move on like this to the numbers here. I will not take 99, but I will take 1, 2, 3, 4. 84 plus 81 plus 89 plus 90. Then I will divide them by 4. Let's go and see this. We'll see the calculator here and we'll go ahead. 84. Okay, here is the calculator. 84 plus, let's see, plus the second number is 81. Control and V. 81 plus 89. Control and C and go to 89 here. Plus the last number is 90. Control and C and go here. 90. Control and V. This will equal 344. We'll divide this time because it is 4 periods. So I will divide by 4. Divide by 4. Then what is the number? 86. Let me return back to check out what was here. Okay, let me check out what was here. Exactly, it was 86. So these are the forecasting, time forecasting periods for one period, and we're using the moving averages for 2 periods and for 4 periods. So this is the way how it works. Let's see as example now. Okay, how about the 89? Same thing. You won't take this year, the year before it, and you will start moving from the 4 years prior to the year which you want. 90, 98, 80, like this way. So here I want this one. So I will take 99 plus 90 plus 89 plus 81. Those are 4. Enough. Then I will divide them by 4. it will give me this number. And you can make this as a homework for yourself, not for me, just for yourself. You can do it for yourself. Okay. So this is the time series in these points. So now here, a new way of methods, a new method of forecasting or trying to look for the future. And of course, it is objective. Like we said, we have two ways for forecasting. We said we have subjective ways of forecasting, and we have objective ways of forecasting. And this is the objective way of forecasting number 4 today we're talking about. It is the moving average model. Moving average model. We mean by the moving average that we give weights. We give weights assigned to every stage or to every period. As example, $60, but I will say I'm probably like 60% I will get $60. Look at this. I will tell you the idea uh, on the board, then we will go to an example in front of you on the board, live example. Like as example now, if I tell you, let's see, this year, you will have $60. Tomorrow, you will earn tomorrow $60. Let's say you are working in delivery or whatever, and probably, but I will say this $60, I won't leave it like this. I will give it a weight. The weight is a kind of like a probability distribution. What do you mean by probability distribution? Very simple words, you will say probably with about 70% or 80% sure. That's what you say. 80% sure that I will make tomorrow from the delivery $60. This is, we call it weight or weight average. What do you mean by this? We mean by this weight because you give it a probability distribution. You didn't say 100%. You are not sure, like the pay, as example, the paycheck. If you are working in a company, you know that you will work tomorrow, you will get $100. But you will get the tips and your work, maybe I'm sure with about 80% that you will get $60. Quietly not sure, but still, okay. When I try to make it in a math model, then I will say this is the amount. Let's say this amount, like this, simply $80, but I want $60, $60, but I will multiply it in the probability distribution, which is 80%. 80%. So 80% is 80 divided by 100. And that's how it works, the same thing. So this will give me $48. $48. This will give me $48. Let me enlarge it. $48. So the wave average is changing from the real area of the incomplete certainty into the risk conditions, which we say we will put a probability distribution for your income. Then you will say this $60 with a probability of 80%. And that's how it works. So this is what I want you to know, because the solution of this example depends on this idea. Let's share the screen back and go to the example. Okay, you might say, "Oh my God, what the hell? Why it looks like this? It looks so complicated." No, no, nothing. It's nothing. It's nothing. It's weighted assigned, and it takes this figure. Let us see. Things always, when you do an example for the students, when you do an example, it becomes very easy. But when it starts like a law, the law in front of you, or the rule, or the basic rules, and then you see it like this, you say, "Oh my God, this is no." Just look at this. It's very easy then. We are actually using two techniques in this example together. Okay. Moving average technique we are using for 2 periods of time, which I did in the previous example, moving average. Then we are taking also the 3 periods weighted moving, this time 3 periods weighted moving average. So we will take, for solution of this example, we have now two things. The first thing is we will take 2 periods. This is based on the question itself. 2 periods, moving average, only moving average. Which is, what is the moving average? The first example which we talk today. The first example which we talk about today. This is the moving average. Okay. How about the second one? The second one is the 3 period weighted moving average forecast. Okay. How will I get it? I will show you how I'll get it now. And this is what is it. This is the example which we are in now, the moving average. Let's see what's going on. Flavius Pizza has recorded the following demand history for each Friday. Look at this. That's what I'm telling you. When we come to the theoretical part, I'll never forecast the future without having past records or records about the past. Never forecast the future without historical records. So, because I said simply, what is the forecasting, or what is the yeah, what is this forecasting? It's trying, where are you, where you want to go, how you will go there. So, it's a decision made right now at the present regarding the future, regarding the future, and basically it depends on the historical data or the past. So, you are in the present, taking information about the future, and in the same time you are depending on the past. This is simply what do you mean by forecasting. Okay, so I want my dear students to know this, and to know that we, without having data, we will never have objective forecasting. Objective forecasting. There is another way of forecasting which we said the subjective, but subjective, this was used like when I don't have data. When I don't have data. As example, they use a method was called Delphi method. Delphi is a place in Greece. The lieutenants and the generals of the wars and the assembly of the Greek Empire, they used to sit there before they go for a war, and they say, based on what we know about the past, what do you think? Shall we go to this war, proceed, or shall we stop and regret about the war decision? Then they will collect the ideas. They don't have data, but they depend on the subjective. We are not subjective now here. We are objective, means we are depending on the numbers. Simply, objective means digits and numbers. That's it. So we will use the two ways. Okay. Has recorded the following demand history for each Friday night. Okay. Develop forecasts for 6 weeks using a 2 period moving average. Okay. Okay. This is the two periods moving average. But he wants for week number 6. Why? Because I have 1, 2, 3, 4, 5. So I need the week number 6. Only week number 6 to forecast the week number 6. We said this before. We said moving average for 2 periods. Simply you will take the last two ones, this plus this, you add them, divide them by 2, because it's a moving average. So the answer of this question, or the first part, the 2 periods moving average, will be as follow. I will do it on the board in front of you. But before I do it on the board, I will show it here. You want number 6, you have till number 5, but you want week 6. You want week 6, this one. That's what you want. And okay, I have till week 5, but I have the data of week 5 and the data of week 4. For week 4, we sold for $73. And for week 5, we sold for $60. So what I will do, based on the moving average of 2 periods, I will take the last 2 periods, which is 73 and 60, and divide them by 2, like here. Then I expect on week 6, though I'm looking for the future, on week 6 to have to sell 66 pieces and half of pizza. Okay, I will do it on the screen, and it will appear to you now. You will see it just now. Okay, now maybe when we write it, it will be so clear. Moving average for two periods for the last, I have period 4 and I have period 5. But I need to explore, to forecast about period number 6. That's fine. That's fine. Then I will take the last two before 6, the last two periods before 6. The sales of the last two periods was 73 plus 60. But he's saying two average of two periods. So, and the word average means summation x by n, means that you have to collect, add them together, divide them, divide them, divide them by 2. If he said moving average for 3 periods, then you will take 3 periods and divide them by 3. If he said the moving average for 4 periods, then you will take periods and add them by, divide them by 4. That's the idea. So here we will work on it by this way, and it will give me this results in front of you, 66 and a half pizza. And that means that on week number 6, because I have till week number 5, on week number 6, which I don't know, I will need 6, I will have to sell, or I will sell 66 and a half pieces of pizza. Moving average for 2 periods, or moving average for 3 periods, based on what he wanted. Okay. Now, let's go back. Let's go back to the example. Okay, we did the 2 periods now. We did the 2 periods now. Now we will move on into the second way, which is the average weight. Now I didn't say the average. The former one, we said 2 periods moving average, only 2 periods moving average, and I kept silent. But here I will say 3 periods, okay? Average? No. 3 periods weighted moving average. What the difference between the weighted and the moving average? Moving average directly, you will gather them, add them together, and divide them by the number of periods. If you said by 2 periods, you'll divide them by 2. If you said 3 periods, you'll divide them by 3. That's it. That's it. But here, he said 3 periods, okay? Weighted. Look at this word. Weighted. 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 Oh, moving average also. But this time, watch out what you will do, because he will give you the scale of weight. Scale of weight means the probability of them. All of them must be 100%, which equals 1 equals 1. So zero point 0.4, 0.35, 0.25, when you collect them, 0.35 and 0.25, this is 60. And this is 40, means 100% or 1. So make sure. If I didn't give you one of them as example like this, made for you like this, okay? And you have two only of the three. Can you get the third? Yes. 100% minus both of them. It will give me the third. So 100% minus 40 and 25, 100% minus 65, it will give me 35.35. Look at this back. We'll return it back the way it is, 0.35. Okay. So here now, we are going to the moving average. For period 6, I need the moving average. That's fine. But moving weighted average for the period 6. Okay, great. Look at this. The 60, I will multiply in 40%. And the 73, I will apply in the middle one, 0.35. And the 55, I will apply in 0.25. Okay, just simply I will make it on the board for you guys to understand it more than just pointing out with the cursor of the mouse. It will be easier to watch it on the board. That will be easier for you, and it will be fine as well. Let's go and see how it works. So just I will take the data, then I will share the screen. I will take data, then I will share the screen. Let me uh, so this is the example in front of you now. This is the example, and what I did just now, I took this example and put it on the board. So I will discuss it from the board. That's what I did. And I will go now. I will stop sharing so I can work in the board. Look at this. I took the example exactly the same way it is. And I have here also the three periods, which 40, I wrote 40%. 35.35, I wrote 35%. 0.25, I wrote 25%. And it's the same. 40.4 is 40%. 0.35 is 35%. 0.25 is 25%. And now I will go to the how I will solve this based on the moving weighted average three periods. Let's start. I will stop share and I will solve it with you guys. We will solve it together now. Okay. The moving average of three periods, that means the numbers which he gave you. The first number should be for the last period. So 60 will be 40%. I will put for it 40% here. Just what I did, I move it from here and I wrote it down. That's it. Now, 73 will be the middle one, which is 35%. This is 73. And the 55 will be 25%. Okay? And this is what we did. Okay, so here we go. Here we go. The first one is 60. Then when I want this future, week number 6 forecast, F means forecast. F means forecast. F6 means forecast week number 6 because I need week number 6. This is question tag. I want this one. Will equal the 60 by 40%, 60 by 40% plus 73 by 35%, 73 by 35% plus 55 by 25%. That's equal will comes to be 63, 60. All of them will equal 63.3 pieces of pizza. And this is the end of the example. So he gave me weights. I multiply the numbers of the last three periods because he said moving average for three periods in the average weights, the probabilities which he gave me. If he didn't give you one of those three probabilities, he gave you two only, you can say 100 minus the other two, it will give you the missed one. As example, if he didn't give me this, I will say 100% minus 40% plus 25%, that will give me 35%. If I missed, if he gave me only two in the example and asked for the third, this was called the moving average period. And this is okay. So here, right? Yeah. Okay. Now we will go to the final thing today in our forecasting in chapter 9, and this is the last thing, which we call the linear regression. And I'm quite sure you guys all, whatever was your studies, except the theoretical, the people who are studying arts before in high school, all of us had this model and we know what is the linear regression model. However, I will discuss it in a way that it will be very clear for all of you. We have y hat equals a hat plus b hat x. Don't worry about anything of this, you will understand it right now. In our model, we have two things unknown, the b, the beta first, and from the beta I will get the time series. So the beta and a, those beta and alpha are the things which I will get. I get the beta first. First, I will work on the beta with this law submission xy minus submission x in submission y by n number of the series. If it is 5 years, then I will divide by 5. 6 years, I will divide by 6. All this is divided by submission x square minus submission x all square. This is different than this. We'll see now from the table how they are different. This will give me b hat. Then after I get the b hat, I have to substitute to get the a hat. So a hat equals y hat minus bx hat. And also y hat, we would see y or y dash, we will see it just now from the example in front of us. Here is an example, claims competition clutches. And actually, this is the last one and the most important of them because this is a very digital and scientific way of forecasting because it depends, it's very acute. It's not like the moving averages, it's more acute than the moving averages. Okay, so we have here the month from month 1 to month 10. So the n will be 10. Our n will be 10, which is the number of the months. And the demands 8, 12, 25, 40, 50, 25, etc. till the end. Then this is how it looks like when we do it historically. Here, what we want just now. Let us apply on the law. Okay, we put the month 1, 2, 3, 4 till the end. So the submission of the months will be 55. 1 and 2, 3, 3, 6, 4, 10, 15, 21, 28, 36, 45, and 10, 55. Why? It's the same thing. So this column and this column is the example, or what is given in the example. Look at this back. We have the month and the demand. You will see this in the real question. Here it is. So this column and this column, those two columns, exactly the same. I will put them when I start the answer on my answer sheet. So I will put this one and I will put this one. Then I will square x. I will get x square. So x square means squaring of this column numbers. So 1 by 1, 1. 2 by 2, 4. 3 power 2, 9. 4 power 2, 16. Okay, 1 power 1, 1 power 2 is 1. 2 power 2 is 4 and extra because this is x power 2 or x square. Okay, so 1 square is 1, 2, and this when I square it means when I power it to 2. 5 power 2 is 25, 6 power 2 is 36, 7 power 2 is 49. Then this is the last one, 10 power 2 is 100, and then I will sum them, they will be 385. 1 and 4, 5 and 9, 14, 14 and 16, 30, blah, 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 till it become, when I do it with the calculator, it is 385. Then I will make another column for xy. I will make a column for xy. What is this column? The numbers of x, I will multiply in the number of y. So 1 and 8 will give me 8. 2 by 12, 24. 3 by 25 will give me 75. 4 by 16, 4 by 40, 160. 5 by 50, 250. 6 by 65, 390. 7 by 36 will give me 252. 8 by 61 will give me 488. 9 by 88 will give me 792. So till the end of this, and I will also sum it, all those 8 plus 24 plus 75 plus 160 it will come to 3069. Now I made the table. Again, the table, X and Y columns are given in the examples. You don't do anything more. They are given to you already in the example. What you will do, you will square X, then you will multiply X by Y, square X and make column for that, and multiply X by Y numbers and make a column for that, which is called XY. So only I will do two columns, X square and Y square. That's what I will do. Copy. Sorry, I forgot to share the screen. I will go back to what I was talking about. I was saying this is the model, the forecasting model, time series yx y hat equals a hat plus b hat x, and I will get the number of a hat and b hat. This is what I'm doing. This is the best way for forecasting, like I said, because this depends on a very acute number. This is the most acute one of them in forecasting. This way, I will get the b. Don't worry about the row. That's the figure of the row itself is very bad rule, but it's not that much. So b equals summation xy minus summation x by summation y divided by summation x square minus summation x all square. This is different than this. Divided by n. N are the number of the series. Like as example, if it's 10 years, then you will divide by 10. If it's 5 years, you will divide by 5. Then this is the b. You got the b by this law. When you substitute with the numbers, you will get the b. Then to get a, substitute in the real equation, y hat minus b hat x. We got the b, so no problem. We will x dash. So we'll get, it will be very easy now when you see an example about this Mike's claim. And what we are saying now is use linear regression to forecast demand for months 11 and 12 and 13, whatever. But use linear regression. So what you will do, the answer is, first of all, I will take month X and month Y and demand Y. So those are given, this one and this one is given in the examples. You won't get in, you won't do anything. You will take them copy and paste, right? You will take them copy and paste. So here they are, months and demand in the example. You will take them copy and paste. This is the months and this is the demand. And their numbers, write their numbers. Only thing you will do, you will add them, the sum. So 55 is 1 and 2, 3, 3 and 3, 6 and 4, 10 and 5, 15, 6, 21, 28, 36, 36 and 9, 45, 45 and 10 will give me this number for 55. And here the demand also, what you will do, 8 plus 12 is 20, 25, 45, and 40, 85, and this 50, 135. Go till you submit it and add all of them. They will be 448. That's nice. Now, what you will do to solve this, till the moment you didn't do anything, you just have the demands and the demand, you bought it from the question. It's given in the question, nothing more. So what you did is you just submit them like this. You add them. The column X and the column Y. You the total amount. You got the total amount for both of them. That's right. Now you want, what you will start to do is x square. You will do a column. You will call it x square. What is x square? The square of this column. Square means power 2. By other simply power 2. So 1 power 2 will give me 1, or another meaning, 1 by 1 will give me 1. 2 by 2 equals 4. 3 by 3 equals 9. 4 by 4 equals 16. 5 by 5 equals 25. 6 by 6 equals 36. 7 by 7 equals 49. 8 by 8 equals 64. 9 by 9 equals 81. 10 by 10 equals 100. Then after you finish the series of the 10 years, you will bring the, or you will add them together, 1 and 4, 5 and 9, 14, 14 and 16, 30, 30 and 25, 55, and 30, blah, 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 and 30, then we'll go, blah, 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 it will come to 385 when you do it with the calculator. Okay, so this is the first column you will do. The second column you will do is you will multiply the numbers of x by the multiply the numbers of y. You will multiply the numbers of x and y. As example, and you will do a column, you will call it xy. So you will multiply x by y and do a column that is called xy. How? 1 by 8 will give me 8. 2 by 12 will give me 24. 3 by 25 will give me 75. That's it. 4 by 40 will give me 160. 5 by 50 will give me 250, and go on and go on and go on and go on, the same, etc. Blah 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 till you reach to the last number and you finish it. 10 years. Then you will add them together. 8, like you did exactly in the previous one. 8 plus 24, 32 plus 75 plus 160 plus 250 with the calculator, plus 390 plus 252 plus 488 plus 792 plus 630. That will give you this number, which is 3069. Great, perfect. We are done now for the schedule. We just did those two. Those were already given in the example. X and Y columns were given in the examples, but we did this column and we did this column. Great, perfect. Now I will apply this in the law or the rule of getting the B hat. So B hat equals summation of xy. Summation of xy is 3069. Here it is, 3069, minus summation x by summation y. Here is summation x is 55. 55. Summation y is 448. So summation x by summation y. Okay, what about the 10 divided by 10? 10 is the number of the series because you have from 1 to 10. So you have 10 month or 10, yes, it's with the months here. So you have 10 months. So you will divide by 10. Okay, this is in the nomination. How about the denomination? Denomination is summation x square. Summation x square is 385. You will tell me x by x. No, 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 no. Summation x is something and summation x square is another thing. So summation x square is 385 minus summation x the whole square. The whole square means summation x is this 55. The whole square means that you will multiply it power 2. So summation x power 2 means summation x, this one, power 2, divide by n, which is the series number. When you substitute and finish, then you will get the B hat. B hat will equal 7.33. Okay. I want also A. I need A because I need A and B. So if I get A will equals y dash. Y dash is the average of column y. So if column y is 44.8, then y dash will be 44.8 by 10. It will give me 44. Let's see again. Let me write it down to you here. Y hat or y dash will equals, it will equal summation y divided by the number n. Okay, summation y. Let us see y, how it was. Y is 448. And the series n is 10 months from 1 to 10. So that's why I will do it like this. Equals 448 divided by 10. That will equals 44.8. And this is the number which we have here. Look at this. 44.8, the average. So here we say y hat 44.8 minus b hat. B hat, I got it, 7.33 here. I'm substituting now by x hat. X hat is here, also the average. The average of 55 divided by number of months will give me 5.5. This is 50 head. The same thing. X, summation X divided by the number of months N equals X is 40. How much is X? Let's see. X is 55. Then X is 55 divided by the number of months. Like you see here, the number of months is 10 months divided by the number of months, which is 10. That will equal 5.5. And here we go. So we just substituting in the numbers, and we got now A equals 4.49 and B equals 7.33. Now, if you want any months, forecast months 11, okay? Forecast months 12, forecast months 13. What I will do is, this point I have to discuss it on the board so it will be clear for you. I will show it to you just on the board now. Yeah. Just stop sharing. Okay. I just want you to keep your eyes with me for what I will do here now after I got the A and got the B. It's very easy. It became very easy. It will take from you 2 minutes to understand it. Let's see here what we will do. We got the A already and we got the B. It's very easy for us now because we got the A and we got the B. We say Y equals A plus BX as example. We got already the beta. The beta is, we got it from the example. Let's see how much was the beta. So beta was 7.33. 7.33. And A or alpha was 4.49. 4.49. Great. He's telling me forecast because he gave me the series for 10 months. And he's asking for the month 11. Forecast the month number 11. So month number 11 will be A, it's like Y. Okay, let us say like this: Y equals A plus BX. So month 11 will be, how much is the A? 4.49. This is the A. Plus the B. How much is the B? B is 7.3. 7.33. Look at this now. Look at my hand. Multiply by the X. Now the X is what? X is 11 because this is month number 11. Okay? And this will give me 85.12, whatever it's clutches or whatever, like the example is. Shoes, clutches, based on what you have, rooms, pizza, what the type of what he's talking about. So what's happening here? Like I told you, we need only to have A and B, and we got it already from the two equations which we had before in the least squares or in the regression model. So what are we doing now? We will substitute in the equation Y equals A plus BX. That's fine. Let's say he wants month 11 equals A. A and B are constants. They never change. They will never change, A and B. But what is changing is the number which he wants. What the number which he wants. So now he wants month 11. That's fine. So 4.49 plus the B, We said 7.23. We got them already before. We got them from the table and from the equations which we did in the previous step. Okay, if you want, can you play? Can you do months number 12? Can you do this? Okay, do it, please. Yeah. Okay, I will help here also. So it will be A also plus BX. Okay, so months 12. We said A and B will never change. The A and B are constants, and we have their values. We have the A and we have the B. They are not changing. So A is 4.49 plus B is 7.33. But this time I will multiply instead of 11, I will multiply in 12. Equals, and this give me the number, the second number, which is here. Instead of calculating it now, we have it already made. 92.45. 92.45. And extra, if he told you the month's number 100, then you will remove the x and multiply by 100. If he told you the month's number 150, then you will remove the 100x and put multiply in 150. I repeat back again and I say that the x and the a and b are constants. They never change. They are the same which you get from the equation. The most thing helpful in the regression model that it gives you a power to forecast for whatever you need. Even if you need to forecast after 1 million year, you will remove the x and multiply by 1 million. So this is how it helps. It's very acute. It's the best of them. It's the powerful way to forecast through all the means of forecast. Thank you so much. This was very long. It may be separated video, or I might attach it to the theoretical part, but I know it's very long and can take 2 sessions to finish it. You have all a good night, and I wish you, my students, my dear students, all the best and all the good luck. Thank you so much for listening to me. Thank you. Bye bye, guys.